we want to start talking about what it looks like to multiply a matrix by a vector. And as it turns out, nothing in this video is going to be that surprising because we've already talked about how to multiply a matrix by a matrix. So for instance, if I have two matrices A and B, we know how to find the matrix product A times B. And we've also said that we can write vectors as either a column matrix, a single column matrix, or as a row matrix, a single row matrix. So if we can write a vector as a matrix, then when we multiply a matrix by a vector, it's kind of like multiplying a matrix by a matrix, and we already know how to do that. So in this video, we're just going to clarify that multiplying a matrix by a vector or a vector by a matrix follows the same rules as matrix multiplication. So let's say, for instance, that we have a matrix, and we'll call the matrix, let's say it's a 3 by 2. So it looks something like this, and we have 1, 0, -2, 4, 0, 1. So this will be our 3 by 2 matrix. And let's say that the vector B is the vector, we'll call it 5, -1. Then if we want to find the matrix vector product, we can multiply these together. We'll multiply A by the vector B, and here's what that's going to look like. We'll take the matrix A multiplied by the vector B, and so we'll have A, which is 1, 0, -2, 4, 0, 1, and we'll multiply that by B, and B will be a column vector 5, -1. And the reason that B is a column vector instead of a row vector or a row matrix is because notice here the dimensions that we've set up for the product of A by the vector B. A is a 3 by 2 matrix. That means that in B, we need to have 2 rows, because remember that with matrix multiplication, the dimensions here have to match. So in order for the product to be defined, the vector B must have 2 rows. So if we had put B in the same spot, but set it up as a row vector or a row matrix with 1 row, we would have a 1 here and our dimensions wouldn't match. We have to have 2 rows, so we set this up as a column vector. And then we say that B is a 2 by 1 matrix, so we know that the dimensions here of the product will be a 3 by 1, 3 by 1. So the result here then will set up for a 3 by 1 matrix, and we'll take the dot product of the first row, 1, 0, with the column vector 5, -1. So we'll say 1 times 5 plus 0 times -1. And then we take the dot product of the second row, -2, 4, with the column vector 5, -1. So we say -2 times 5 plus 4 times -1, and then we do the third row, 0 times 5 plus 1 times -1. And the result here, when we simplify, will be 5 plus 0 is 5, -10 minus 4 is a -14, and 0 minus 1 is a -1. And so the result of A times the vector B is the vector 5, -14, -1. Now let's do another example where we take the vector and multiply it by the matrix, so we go the opposite way. Let's say we want to find the product of the vector W multiplied by the matrix B. So notice how here we had the matrix then the vector, here we have the vector then the matrix. If we want to find W times B, let's say that W is a row vector. We'll say 1, 0, -2. And the matrix is a 3 by 2, let's say 3, -4, 1, 0, 0, and -2. Something like this. Again, going back to dimensions, we see that we have a 1 by 3 and we have a 3 by 2. So we know that our product is defined because we have these values that match. And then we know that the dimensions of the result will be a 1 by 2. So we can set up here for a 1 by 2 result. And when we do, we'll take the row vector W and multiply it first by the first column of B, and we'll take that dot product. So we'll say 1 times 3, so 1 times 3 plus 0 times 1 plus 0 times 1 plus negative 2 times 0, or minus 2 times 0. That's the row vector by the first column. Now we need the row vector by the second column. So this will be 1 times negative 4, and then plus 0 times 0, so that's just going to be 0. We're trying to save space here. And then plus negative 2 times a negative 2 is a positive 4. So we'll get a positive 4 right there. And when we simplify this, we'll get 3 plus 0 is 3, minus 0 is still 3. So we'll get 3, and then here, 1 times negative 4 is a negative 4. Negative 4 plus 0 is still a negative 4. Negative 4 plus 4 is a 0. And so the resulting row vector here, the vector W times the matrix B, is equal to the row vector 3, 0. The thing we want to notice here with both of these examples is let's always say that the dimensions of a matrix will be m by n. So we'll have m rows and n columns. We'll say the same thing over here, an m by n matrix. That means here that when we multiply by the column vector has to be n rows by 1 column. If we multiply over here by the row vector, that means we're going to have 1 row by m columns in order for the products to be defined. Notice here how the n's match here. We have n columns and n rows. Those match, so the product is defined. And over here we have m columns and m rows. Those two match, so the product is defined. What we see is that if we look at the dimensions of the product of this A times the vector B, the dimensions of the product are always going to be m by 1. So this down here, the result, is an m by 1 column vector. If we look at the dimensions of the result over here, the dimensions of the result are always going to be 1 by n. So this is a 1 by n. So what we're saying is that if we multiply a matrix by a column vector, the result of that will always be a column vector because we're always going to end up with 1 column. So the result will always be a column vector, and it'll have the same number of rows as the matrix. So it's going to be the rows of the matrix by 1 column. It'll be an m row column vector. That will always be the result of multiplying an m by n matrix by an n by 1 column vector. And then similarly over here, when we multiply the row vector by the matrix, we're always going to get a row vector because we have 1 row here, and the number of columns in that row vector n comes from the number of columns in the original matrix. So we're always going to have an n column row vector when we multiply a row vector by a matrix. And that's a good way sort of to do a dimensional analysis when you're multiplying by a column vector or a row vector to know quickly the kind of result, the dimensions of the product that you're going to get, whether it's an m row column vector when you're multiplying by a column vector or an n column row vector when you're multiplying by a row vector.